Alright, so for this question, this is a tricky one. So limit, we're asked to find a limit as x approaches 0 of x sine 1 over x. So we can start by plugging in 0, right? So 0 sine 1 over 0, which is undefined, so you can't do that. That doesn't work. So now we're going to use something that's called squeeze theorem. So we know that a basic sine function will look like this, right? Where the highest it can go is 1 and then the lowest is -1. So as long as it's like has a sign, it'll stay between the numbers 1 and -1. So we know that the lowest it can go is -1, inclusive, sine x, and then the highest it can go is 1, right? So since this applies to anything with sine, it'll apply to x sine 1 over x. So you can do negative x is less than or equal to x sine 1 over x less than or equal to x. Right. Well, okay, to get from this to this, you just want to, oh no. Okay, actually, let me explain step by step. So, do you understand up to this point, -1 is less than or equal to sine x less than or equal to 1 because of the sign. So, that will be the same for sine 1 over x. So, -1 sine 1 over x less than or equal to 1. So since it's the same there, now what do we do about this x? We just need to multiply. So this is x times sine 1 over x, right? So you need to multiply this by x. So if you multiply this by x, you have to multiply the other two. So -1 times x is -x. And then x sine 1 over x, which is our original question. And then 1 times x is x. Right. So, and of course we're asking to find the limit. So limit as x approaches 0, and then that's for all of these. So what is the limit as x approaches 0 of -x? So you want to plug it in, right? So -0, which is 0. And then this is what we're trying to find, right? Let's go here. Limit as, this is limit as x approaches 0 of x, which is, you plug it in, x equals 0, so it's 0. So what is in between 0 and 0? Well, that would just be 0. So that means your answer for this, which is kind of messy, but that says limit as x approaches 0 of x sine 1 over x, which is our original question. That answer is 0. So that's how you figure this out using squeeze theorem.